Hello everyone and welcome to the normal distribution. In today's talk we are going to discuss one of the well-known continuous distributions is called normal or Gaussian distribution. So the normal distribution is a continuous probability distribution. Right, so let me give you an example of normal distribution. So suppose we are dealing with students' GPA. So suppose this is the GPA, all right? So suppose you have a large data set about the student GPA. So let's say the mean is 3.1. The mean is 3.1, okay? And of course, the largest value is 4, and maybe the lowest value is 2 or 2.1, whatever. So if you look at this large data set and if you create a histogram, you will see some students, or the majority of the students, they have GPA around the mean. And small proportion of students, they have very high GPA. And unfortunately, small proportion of students, they have very low GPA, but the overall shape looks like this. So this is an example of a normal distribution. All right, so it's a continuous distribution because in x-axis, we don't have just integers. It's not discrete, like GPA. Your GPA could be 3.17 or 3.94 or 2.89, right? So this is a continuous distribution. And the shape looks like a bell shape, and it's symmetric about the mean. This means if this is the center, and you make like a vertical line, I keep pressing, sorry. If you make a vertical line here around the mean, then the right-hand side and left-hand side should be very similar. So this is the meaning of symmetric distribution. The normal distribution has two parameters, the mean and the standard deviation. The mean is called mu. So mu is the mean, and sigma is called the standard deviation. So those two parameters describe the normal distribution. As I mentioned, the center is mu, and the entire area or the entire probability under the curve is 1. So those are some properties of the normal distribution. One more thing is, because the area under the curve is 1 and the normal distribution is a symmetric distribution, so this probability here, this probability to the right of the mean should be 1/2 or 50%. And this probability here should be 50% because the area under the curve is 1 and it's symmetric, so we have 50% to the right of the mean and 50% to the left of the mean. All right, so those are some properties of the normal distribution. As I mentioned, we have two parameters for the normal distribution, mu and sigma. What does the mean or what does mu do? So mu determines the center of the distribution. So as you see here, this is mu, the mean or mu. It's the center, and you can move when you change the value of the mean. This means we shift the distribution to the right or to the left, right? But don't change the shape. So if we change mu, then we shift, if it's greater than 3.1, we shift it to the right. Less than 3.1, we shift the entire curve to the left. But the shape should be the same, but we change the center only. However, when sigma describes the spread of the data, right? So the standard deviation measures the spread. For example, when the standard deviation or sigma is small, this means we have less spread. So we expect to have narrow and tall curve. For example, something like this, when the standard deviation is small. So we have narrow and tall. However, when sigma is large, we should have more spread, which means something like this, right? So they have, let's say they have the same mean. So the center is the same value of mu, but sigma describes the spread or the deviation. Sigma is small, we have less spread. Sigma is large, we have more spread. So those are the two parameters of the normal distribution. There is a very important rule. It's called the empirical rule, or it has a name. It's called 68-95-99.7 rule. So what is the meaning of that? So the empirical rule tells us the following. So if we have a normal distribution with mean mu and standard deviation sigma, then about 68% of the data should be between or within one standard deviation from the mean. For example, suppose this is our normal distribution. This is the mean. And this is sigma or 1 sigma. This is 2 sigma. And we have 3 sigma. Similarly, we have negative 1 sigma, negative 2, negative 3. So the empirical rule, or 68-95-99.7 rule, says if we are within one standard deviation from the mean, which means if we are in this area, this is negative sigma to sigma, then this probability or this area under the curve is about 68. It's approximately 68%. Okay. Now, if we are 2 standard deviation from the mean, which means if we are here, then the entire area or the entire probability between negative 2 sigma and 2 sigma, this probability from here to here is about 95%. So this is the meaning of the title or the name of the rule, 68, 95, and 99.7, which means if we are 3 standard deviation from the mean. So we are almost cover everything. It's not 100% or one, it's about 99.7%, all right? So this is the meaning of the empirical rule. So if we are 1 standard deviation from the mean, then the probability is 68%. If we have 2 standard deviation from the mean, then the area or the probability is 95%. If we are 3 standard deviation from the mean, then we have approximately 99.7% probability. So it's very nice rule. All right, so let's apply the empirical rule. Suppose exam score are normally distributed. The mean is 80 and sigma is 5. What percent scores above 90? So I'm going to use the same graph here. I just want to change the label of mu and sigma because now I have specific values of the parameters. All right, so instead of mu, I'm going to write the exact value of mu and the exact values of sigma. Right, so based on this example, mu is 80 and sigma is 5. So I'm going to add 5 here. So 85, 90, 95. And if you subtract 5, so this is 75, 70, and 65. So the question is, what percent score above 90? Okay, so above 90 means we are here. This is the area above 90, right? This pink area is the probability above 90. Okay, so to answer this question, We know that if we are between 70 and 90, then we are in the 95% probability, right? So, or again, the area between 90 and 70 is 95%. So this means the two areas above 90 and below 70, those two areas is 5% because the entire probability or the entire area under the curve is 1. Again, this area plus this area, both of them is about 5%. They have 5% probability. But our question is about the area above 90, not the area below 70. Okay. So this probability should be 5% divided by 2. Why divided by 2? Because the normal distribution is a symmetric distribution. This is one of the nice properties of the normal distribution, which means this area to the right of 90 is exactly the area below 70. So the answer is 1 minus 95%. It gives us the area, the two areas outside, right? But because we are interested in the right-hand side area above 90, we just divide by 2. So 5% divided by 2, it should be 0.025, or we can say 2.5%. All right, so I hope this is clear, and this is one of the applications of the empirical rule. All right, so some of you may ask the following question. How can we find the probability above 92? Okay, for example, what is probability x is greater than 92? Now, 92 is not mu plus sigma or 2 sigma or 3 sigmas, right? So in this case, we can make a guess based on the empirical rule, but we cannot find the exact number because the empirical rule has restrictions. It tells us the area or the probability within 1, 2, or 3 standard deviations from the mean. 92 is not one of those cut points, so we cannot use the empirical rule to answer this question. We are going to answer this question in our next session when we deal with the area under the curve. And the idea here is to use something called a standard normal distribution or the z-table to find the probability. So remember this for the next meeting. All right, so the last thing is why the normal distribution matters. So the answer is because the normal distribution has so many real-world applications. For example, today I mentioned the student's GPA. The question in general, the GPA follows a normal distribution. The student's height, the student's weight, the student's test scores, those are examples of normal distribution, all right? So because it has so many real applications, the second idea or the second goal of the normal distribution is because based on the normal distribution, we can create, or it's the foundation of the confidence interval and hypothesis testing and the central limit theorem. We are going to discuss those topics in details in the next meetings. But those are very important topics in statistics. Again, confidence interval and hypothesis testing, those are about the estimation. We use the normal distribution for that. So normal distribution is a very important distribution and a very important continuous distribution. It has so many applications. That's it. Thank you very much for watching.